This is Math 96, Quiz Topics 2, Power and Quotient Rules with Negative Exponents. Our first example says, simplify, right answer using only positive exponents. So we have this fraction inside of parentheses and outside an exponent. Whenever you see a negative exponent, we're to move what it applies to the opposite end of a fraction. In this case, a -1 exponent would mean taking the reciprocal of this entire fraction inside the parentheses. So let's start by doing that. We'll rewrite the denominator up in the numerator. 20m to the -8, n to the -4, p to the -2, all over 8m to the 8, n to the 6, p to the -7. Okay, next, I want to point out that each of these exponents applies only to the variable right next to it. So, for example, this -8 applies to the m, but does not apply to the 20. If we wanted it to apply to the 20, we'd have to have parentheses around both of these. And so, anytime we see a negative exponent, like I said, we can move that portion to the opposite end of the fraction. So this, and this, all the variables in the numerator will end up moving to the denominator. So let's rewrite the fraction as 20 over 8. M to the 8th is already there. And then I'm going to move this m to the -8 from the numerator down to the denominator, and it becomes m to the +8. I'm moving n to the -4 down, and that will become n to the +4. We already have an n to the 6 in the denominator, and it stays put. I'm moving down the p to the -2. It becomes p to the +2. And then I have p to the -7 in the denominator, and so it moves up to the numerator and becomes p to the +7. So now I want to see if I can make this more concise by combining any bases that are the same. So m to the 8th times m to the 8th, I use the product rule, which means I would add the two powers, 8 plus 8, and make that m to the 16. So I now have 20 in the numerator, 8 in the denominator, m to the 16, and then I can combine n to the 4th times n to the 6th by adding their powers, 4 plus 6 to make 10. So that's n to the 10. Finally, I look at these p's, and one is in the numerator and one in the denominator. And so I'm dividing two bases that are the same. So I use the quotient rule, which says that we subtract the exponents, 7 minus 2. And when we do that, we always put the answer in the numerator. And so this will be p to the 5th up in the numerator. Okay, so my variables are all as simple as possible. Now I just need to simplify the 20 over 8. This would be just like simplifying a regular fraction, 20 over 8. I look for a greatest common factor, which would be 4. I can divide 20 by 4 and get 5. I can divide 8 by 4 and get 2. And then the p to the 5th remains the same. M to the 16th and n to the 10th remain the same. And so this is my final answer for the first problem. My second example says, simplify, right answer using only positive exponents. You notice I have another fraction, this time with parentheses on top and an exponent on the outside, and a different set of parentheses and exponent on the bottom. And so I'm going to simplify this negative exponent by moving this entire set of parentheses down to the denominator of the fraction and making that a +3. That would leave me just a 1 in the numerator. And so everything is in the denominator now. A to the -6, b to the 4th, all raised to the third power. You notice that these inside exponents do not change. All that I've done is moved this whole thing down to the denominator because of that negative exponent, and that exponent becomes positive. I still have 4a to the 6th, b to the negative 4, raised to the second power. And so now I simplify each of these individually. I'm going to apply this third power to each of the terms on the inside, actually each of the bases on the inside, I should say. And so I still have 1 in the numerator, and then I multiply the 3 times the negative 6, making that a to the negative 18, and b to the 4 times 3, so b to the 12. And then here, I have to square the 4, and so that's really a 4 to the first, so 4 to the 1 times 2 is 4 squared, or 16. A to the 6 times 2 would be a to the 12, b to the negative 4 times 2, so b to the negative 8. Okay, let's simplify by moving all of those bases with a negative exponent to the other end of the fraction. So this one and this one will move up to the numerator, giving me a to the positive 18, b to the positive 8, over, let's move our 16 to the front of that denominator, and then put these in alphabetical order, a to the 12, b to the 12. Okay, now I have division of the a's and the b's, and so I can use my quotient rule, which says to subtract the powers and put the answer in the numerator. So a to the 18 minus 12 would be a to the 6th, and b to the 8 minus 12 would be b to the negative 4. Both of those in the numerator. I still have my 16 in the denominator. Finally, because I want my answer to have only positive exponents, I still need to move this b to the negative 4 down to the denominator. So I'd have a to the 6 over 16 b to the 4th. This should make sense as you look back at this step, because this means there were 8 b's in the numerator, 12 b's in the denominator. If I canceled 8 of those that they had in common, that would leave 4 b's in the denominator, and that is what we have in our final answer.